All right, so we just looked at the overview information for an ellipse. Now we're going to look at graphing those. So we're going to look at pretty much two different types. So one type is going to be like number 1 and 2. They're going to start at 0, 0 for our center. Because as you can notice in our general form that we wrote down, whenever we have just x squared or y squared, that just means that h and k are 0. Those are a little bit easier to graph. Then we're going to look at 3 and 4, which are just a little bit, it's not that they're hard, it's not as easy. So we're going to look at both of those, and then we will, then in the next section, we'll get to some equations. So when we're graphing these ellipses, first thing we're going to do is write the equation in standard form. I'm already going to give it to you in standard form because I just don't want you to have to do it not in standard form. The next thing we're going to do is graph the center, which is h and k, and that comes from our general form that we went over in the last video. Then we're going to graph the vertices, which is the larger denominator. So when we're looking at each of these fractions that we have in 1 through 4, whatever the larger denominator, whichever denominator is larger, that's A. So that's our major, essentially that's telling us where our major axis is, because those are our vertices. And then, I'll get to another point that it tells you. There's a lot of tricks that these kind of give you just by looking at the equation. All right, so then the co-vertices, that's using the smaller denominator, which is B. So that's going to be like our minor axis. That's kind of our hint there. That's what it's telling us. And then we're going to use the formula for finding the foci as well, which is c squared is equal to a squared minus b squared. And that part's not too bad because we're going to use our calculator a little bit for that part. All right, so then what this is essentially telling you with your larger denominator and your smaller denominator is if your larger denominator is under the x squared or wherever the x fraction is, or x in the fraction, that's telling you that you have a horizontal ellipse. So that's going to tell you that it should look kind of like that. It should be longer at its width than, or longer horizontally than longer vertically. And then it's also, if your larger denominator is under y, like in number 1, that means we should have a ellipse that looks kind of like this. It should be longer vertically than it is horizontally. So those are just some tricks to note. But all right, so we're going to graph number 1. So number 1, we're going to first look at our center and graph it. So what would our center be here? If we go back to our general form, when we have x squared and y squared just by themselves on the top of our fraction, it tells us that our center is at 0, 0. So our first point is right here at 0, 0, which I jacked that all up. Let me change it. First point is right there. All right, so now we need to know our vertices. And for that, we're going to use the larger denominator. So between 4 and 36, which one's larger? 36 is larger. So in our general form, whatever number's on the bottom is actually, and larger is actually a squared as it is written in our general form. So all we have to do is take the square root of whatever this number is, and that will give us a. So if a squared is equal to 36, that means that a is equal to 6. So our vertices here are actually plus and minus 6. So that just means that we can count from the center to the right 6, or actually to, since it's under the y term here, that's telling you our major axis is vertical. So we'll go up and down 6 from the center. So we'll go up 1, 2, 3, 4, 5, 6 right here, and then down 1, 2, 3, 4, 5, 6. So remember, if your larger denominator is under the y term, that means that you're going to be counting from the center of your ellipse up or down. And if it's under the x term, that means you're going to be counting right or left. So our vertices here are these points after we count up or down. So that point, this point here would be 6, 0, or actually it would be 0, 6, and then our other point would be 0, negative 6. So those are our two endpoints. And then we're going to look at our co-vertices, which our smaller denominator is going to tell us that. So if our smaller denominators are co-vertices, that is b. And in our general form, it's actually b squared. So b squared is equal to 4. So that means that b is going to be equal to 2. So we're going to use that because if you remember, we said our co-vertices were plus or minus b units from the center. So since it's under our x coordinate or our x term here, we know that we're going to count right or left 2 units, and those will be our co-vertices. And we're counting from the center. So we're going to start at the center and go 1, 2. That would be right here. We're going to go to the right 1, 2, and then we'll go back to the center and count to the left 2. So 1, 2, that would be right here. So those 2 points here are going to be our co-vertices. And those 2 points are at 2, 0, and negative 2, 0. And that is our graph. We don't really need the foci to actually graph this. That's really all we need. This is really all we need to graph this, which mine might be kind of ugly. But that's what this ellipse would look like. And remember, I told you, since our larger denominator was under our y term here, or this variable y squared, that tells us that we have a vertical ellipse. And we can see that here. This axis of symmetry right here is longer than this horizontal axis of symmetry. All right, now make sure that you have all of this here written down because I'm going to show you how to do the foci next, and it's not too hard. So the foci is, if you remember, it is taking c squared equal to a squared minus b squared. And these are really easy to do because we already figured out what a squared and b squared were. We already wrote those down. So all we have to do is really plug those in. A squared was 36 because that's our larger denominator. And it's already squared. It's already a squared as it's written in our general form. So we don't have to change that. And then it's going to be subtracted by our smaller denominator, which is 4. And just make sure that you notice that this is c squared, not just c. So we're going to have c squared is equal to 32. And then to figure out what c squared is, we have to take the square root of each side. So c is going to be equal to the square root of 32. And the square root of 32 is approximately, you can just use your calculator, it's approximately 5.66. All right, now here is how you actually find those 2 points for our foci. So our foci are plus or minus c units from the center. So we're going to take our center, and all we have to do is add 5.6 to our either x or y values, and we're going to add or subtract 5.6 to our x and y values. So we know we're either going to add or subtract the foci from one of these two values on our center. And the way that we figure out which one to use is you ask yourself, where was my major axis? Because if you remember, I told you our foci has to be on our major axis. And our major axis is actually our longer axis of symmetry, which will be our vertical axis. So that means we're going to add and subtract this foci to the y values from our center. So we're going to take the center and we're going to add 5.66 to the y. So that would be 0, 5.66, and it would be 0, negative 5.66. So that's a big part of this that you have to remember. You have to remember where to add or subtract your foci to. You're either going to add or subtract it to the x or the x coordinate from your center or the y coordinate. And the way that you find that out is you could do it a couple different ways. You could say what kind of ellipse did I have here? Since the vertical axis of symmetry is longer, that tells you you're going to add it to your y coordinates because that foci has to fall on that vertical line. So we're going to add or subtract them to that. Or you could go to your vertices and you could say, okay, I know my vertices here are changing. So that tells me that I'm going to do the same thing. I'm going to apply my foci to the center y coordinate, but it's really whichever way you want to do it. It's probably best to do it after you graph it, because then you can obviously see which line is longer between your vertical axis of symmetry and your horizontal axis of symmetry. All right, so I'm going to do another one, but I'm going to do this one a little bit quicker, and then I'll slow down for 3, and then I'll do 4 a little bit quicker. All right, so when we look at number 2, we need to first graph our center, and our numerators on each of our fractions are just x squared and y squared, so we know our center is 0, 0. So that's going to be right here. Now my vertices will come from the larger denominator. So this here is going to be a because it's larger. It's actually a squared. So my vertices are going to be plus or minus a units from the center. So if 64 is a squared, that means that a is just going to be 8. So I'm going to take 8 and I'm going to add it and subtract it from the center. And this 64, the greater denominator, the larger denominator, is under my x squared. So that means I'm going to go 8 units to the right of the center. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go 8 units from the left. So this is going to be a horizontal ellipse. So it should be wider horizontally than it is vertically. So my center, or my vertices here, are actually going to be 0, or it's going to be -8, 0, and 8, 0. And it's probably easier just to count a units to the, or plus or minus a units, which is 8. So plus or minus 8 units to the right and left, and then just use those points as your vertices. So now my co-vertices come from the smaller denominator, which is 25. So that's b squared. So if I want to know what b is, if 25 is b squared, that means the square root of 25 is going to be 5. So b is just 5. So I'm going to apply plus or minus 5 units from the center up or down, because those are under the y variable. So that tells us to apply that to the y variables from our center. So we'll count up 5 units. So 1, 2, 3, 4, 5. And then we'll count down 5 units. 1, 2, 3, 4, 5. So we're counting from the center again. So those points there would be at 0, 5 and 0, -5. And then our foci is doing the same thing we did with number 1. So we're going to be, make sure that you've got all this to the left written down. Our foci is going to be c squared equal to a squared minus b squared. And our circle, or our ellipse, would actually look something like this. Actually, let me try that again. That's a little bit better. And you can see here it's wider horizontally than it is vertically. So that just tells us our horizontal axis of symmetry is our major axis. All right. So back to our foci, c squared is equal to a squared minus b squared. So c squared is going to be equal to 64 minus 25. So c squared is equal to 39. And then we're going to take the square root of that to actually get our foci. So the square root of each side. So c is going to be equal to the square root of 39, which is approximately 6.24. So our foci is c is equal to 6.24. And what we do is we take plus or minus c, or plus or minus 6.24 units from the center, but we need to know, are we doing that to the x-axis or the y-axis? And since our horizontal axis of symmetry is our major axis, then that means that our foci has to be on this line. So we're going to apply our foci plus or minus to our x-axis, which is our x-coordinates. So our x-coordinates from our center will have minus 6.24. That's when we subtract it. And then we'll also have 6.24. That's when we add it. So now we'll go to 3 and 4. And this video may be a little bit longer. I apologize, but these are a little bit difficult to understand. All right. So we're going to graph 3 and 4. They're just a little bit different, but they're not too much. It's just really the co-vertices and the vertices and the foci. It's not too confusing, but it's just a little bit different. It's a lot easier when it's 0, 0. So our center here is going to come from what is inside these parentheses with x and y. We just have to remember when we take those out, the sign flips. So on the x term, or in that parentheses with x, we have a positive 1. So when it comes out for our center, it's -1. And then when we have -2 in parentheses, that means that it's just going to be 2 for the y coordinate in our center. So that is our center. Our center is right here at -1 up to right there. So that's our center. Now we need to know our vertices. And our vertices comes from the larger exponent, or the larger denominator. So the larger denominator here is 49. That is a squared. And that tells us that if a squared is 49, a is just going to be 7. So our vertices here are 7, and we need to know, are we counting to the right or left from the center, or up or down? And since it's under the x variable, that tells you that you're going to go right and left. So we're going to go 7 units to the right of our center. So 1, 2, 3, 4, 5, 6, 7. That'd be right here. And then we're going to go 7 units to the left. So 1, 2, 3, 4, 5, 6, 7. That'd be right here. So those are our vertices. So all we have to do now is plot those points, or look where those points are plotted, and the ordered pair for each are going to be our vertices. So our first set is going to be -8, 2. Our second set will be 6, 2. So that's each of those endpoints for our vertices. Then for our co-vertices, we look at the smaller denominator, and that tells us what b squared is. And if b squared is 9, that means that b is just 3. So then we're going to take those, and since we did our vertices to the right and to the left of the center, for our co-vertices, we're going to go up and down. So we're going to go up 3 units from the center, so 1, 2, 3 right here. And then we're going to go down 3 units, 1, 2, 3 right here. And each of those points will tell us our co-vertices. So our co-vertices will be, let's see, -1, 1, 2, 3, 4, 5. So -1, 5. And -1, -1, I believe. Yep. All right. So that's everything we need for our graph. That is what our graph looks like. And if you remember, I said that your larger denominator is going to tell you what type of ellipse you have. Our larger denominator was under x, so that tells us we're going to have a horizontal ellipse, and that's what we have here. Last thing we have to worry about is the foci. So the foci here will be c squared is equal to a squared minus b squared. And we already know what a squared and b squared are. It's just our denominators. So you're going to take the larger one, subtract it by the smaller one, and then you'll get c squared is equal to 40. And then to finish this off, we need to take the square root of each side. So c is going to be equal to the square root of 40, which is approximately 6.32. So that's our foci. And now if you remember from our notes in the last video, our foci is plus or minus c units from the center. So our foci will be this 6.32 plus or minus 6 units, or plus or minus 6.32 units from the center. We have to know whether we add that or subtract that to our x coordinate, so either to -1 or our y coordinate. And the way that we know that is wherever your larger denominator is, whatever coordinate that's under, or whatever variable that's under, that's the one you're going to pick. So in this case, we're going to take 6.3 and add it and subtract it to -1. So we'll get, and then we'll just keep 2 from our center. So we'll have, when we add it, we'll get 5.32. So we'll get 5.322 as one of our points and negative 7.322 as our other point. So when we add or subtract our foci, that's where those points are, which those points would be like right here. I'm not going to really make you graph those. We just have to remember that it's going to be on our horizontal major axis. So in that case, we would have done this problem correctly. Now the last one, I kind of want you to attempt that. We may go over that one in class. But it's really the same part. The only difference between when you have a center at HK and when you don't is just the adding, or it's just a little bit harder because when you add to the center, your foci to the center, it's just not as obvious. Here, it's easy to spot these zeros, and it's easy to add your foci to the zero because it's just the foci. But that's how we're going to graph these ellipses, and then we'll go over this more in class.